So this session, so there are some properties that are quite different and worth paying attention to. Knowing these properties, it is then easier to formulate large problems with matrices for easier solution. So this session outline, at the end of this session, we should be able to define matrices, understand the properties of matrices, perform matrix operations, which is you should be able to add, subtract, transpose, multiply matrices, and then understand identity and inverse matrices. Then we should be able to transform a set of linear equations into matrices. So we will be able to cover all of this, but not in this particular one and because we should be able to go through this one by one, so that we get a clear understanding. I won't be rushing with this one. So they also told us to read a chapter 2 of Winston and Goldberg. So basically, if we see matrix, right, it is basically any rectangular array of numbers, but it can be either rectangular or it can be square. The reason why I'm saying it can be square is when it is, let's say, 1, 2, 3, 1, 2, 3, 1, 2, 3, right? It is a 3 by 3. So 3 by 3 will make it what? A square. But if it is 1, 2, 1, 2, 1, 2, this is a 3 by 2 matrix, which will make it what? A rectangle. So basically, we can just define it based as a rectangular array of numbers or a square. They are all in simple form. It is an array of numbers. So a number that will be in an array. So that's basically what a matrix is. So me, I'm not sure, say maybe session A never there, because so far, past questions that I've seen, it's a definition for matrix simple. In the sample, like it is nowhere near. So regarding maybe an objects, they are fine. It's okay if you understand what matrix is. So for example, we have this matrix here. We have this matrix here, which is a 2 by 2 matrix, which is we have 2 rows and then 2 columns. So this is a 2 by 2 matrix. We also have this as a 3 by 3 matrix. This is 1 by 2 matrix. We also have 3 by 3 matrix. So as we knew in SHS, in JHS or SHS, normally when a teacher comes to class and they say this rule, stand up, but indicating this side like this, but it wasn't the right way. This is rather a column, and this is rather a row. So the row is here. This is a row. And then this will be the column. The column will be the ones here. So cow, A-L, A-L is column. And then horizontal, R-I, horizontal is row. So vertical is column, horizontal is row. If you're able to grab this, matrix then share that in your thing. Most often it confuses people about how like what vertical is or what is. So basically you need to know what column is so that it will be easier to identify the matrices and know what you are doing. So basically, as it is also stated here, this is the row and this is the column. So horizontal row, and then vertical column. So this is how I used to identify the rows and column of matrices. So, okay, so please, up to this point, is there any question? So here they are saying that the definition of matrix algebra. So if a matrix A, which is this matrix, has m rows, right, and then n columns, then we can call a matrix A m times n matrix. So which means if we want to break it down, it means that we can call matrix a row times column matrix. So they've replaced the row and column with m times n. So if matrix A has m rows, which is the same thing, rows and n columns, then we can say we call A and m times n, so meaning row times column matrix. We refer to the row times column matrix as the order of matrix. In general, a typical m times n, which is the same as row times column. Almost the same as okay. Matrix may be written as this. So here is the matrix as the same thing. The same thing can be 1, 2, 1, 2, 3, 1, 2, 3. We can also we can just say we and one we like this. So here will be the rows, and then here will be the columns, right? So it will have 3 columns and then 3 rows. So the number in the ith row and the ith column of A is called the element of A, and it's written id. So if you want to for, let's say, a particular number in the, if you want to look for a particular number in the matrix, you can simply do it by saying, say maybe they can tell you to locate, maybe they can tell you to locate 3, 2. So meaning that look for row 3 and then column 2. So this will be 3rd row and then 2. So this will be what you'll be picking from here. So this is basically what they're explaining here. So as they are, there is the example here. So they can tell you this is a 3 by 3 matrix. So if they tell you to look for A, which is they've named this as A. 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 So they want to look for the A, the third row, and then the third column. So the third row is here, and then the third column is here. So the answer is what? 8, which is here. So if they tell you to look for, let's say, A, 2, 1. A, 1. Augustina, what will be the A21? Looking at this, what will be the answer?
3.
3. Are you sure? Why is
This
it?
is the column.
Why is it 3?
Wait. Column. Okay, row first. So second row. Second row is 4, right?
Second row, they are telling you to look for the number at the second row and then the first column.
First column. Okay, 3. Hey. Oh.
Let's do this. So this is the row. This is row 1, and this is row 2. Right? This is row 1, this is row 2.
Yeah.
And this is the first column. This is column 1. So row 2,
Okay.
and then row 3. And then column 1, column 2, column 3. So you are, so for this particular one, the answer is this one, because this is the row 2, column 1. You get it?
Yes.
Okay, so what if you are told to look for, let me see, 3, 2, 3. What will it?
So second row, A, column 3, 8.
Eh?
8. Wait, so A.
In that hole.
So this one is second row. The second row is 4. And then column 3. Yeah, I'm confused.
What's confusing you? The rows and columns.
I think I'm still not getting.
I've labeled them for you here. This is rows, and this is the columns. So you are looking for it. Always know that a matrix, as we started, a matrix is always equal to, a matrix is always row times column. So we always look for row first before we come to column, right?
Okay.
So this is correct.
So second row.
Second row, and then third column.
Third column. So third column. So like the thing is, so which you see like this C3 here.
Yeah.
You see the numbers there is 3, 6, and 8, right?
Yeah.
So is it that you choose the number corresponding to the row they spoke about?
So first you count your row. 1, 2. This is 1, 2, right?
Yes.
And then now you count your column. 1, 2, 3. So this should be your answer.
Oh, okay.
You get it now?
Yeah, yes.
I should give you another one.
Yes, another one.
So you look for A, 3, 2.
1.
Good. So what of A, 1, 1.
2.
All right. So now you understand it, right?
Yeah.
Okay, good. Prince Inkum.
Yeah, boss.
Good evening.
Even though, Chairman.
Please, I hope you are fine.
Yeah, bro.
Okay, please, so far, do you get what you are doing?
Oh, yeah.
Okay. So can you locate A to 1 for me? A to 1.
That's 5.
Okay. All right.
5.
Yeah. Correct. Thank you very much. Thank you very much. So let's continue. So Mr. Augustine, you are okay with this part, right?
Yes.
So always know. You see, in school, way back in SHS, they rather tell us, rule is this one. Right? No, this is column. So always, when you see any matrix and maybe you think it will confuse you, start labeling it. Column 1,
Okay.
column 2,
Column 2.
and column 3.
Column 3.
Right? And the row to row 1,
1,
2,
row 2,
and row 3, like
row
that.
3.
So that
Okay.
it cannot confuse you. So let's continue. So now we are moving to the same thing, but they said about a vector. So vectors, a vector being of dimension n is an n times 1 matrix rectangular array of elements. So do you remember n?
Yeah.
N was what? Way back here. What did
Column.
I say? So it means what? Column times what? 1.
1.
So as we are seeing here, so column here. So now this will be like row 1, row 2, row 3, row 4, and then 1 column. So a vector of the form V is a column vector. The transpose column vector is a row vector. So if you transpose it, when you reach transposition, when we reach there, you see that when you transpose any matrix, the row will become column and then the column will become row. It's like turning it upside down.
Okay.
So instead of it being V1, V2, this, and then it will tend to like this. V1, V2, then this will come, and then V. So you see it has changed.
Yes.
So if
Now
you
it's in a row form.
yes, if you transpose it, this is how it will be like. That's what they mean. So let's move on. I want us to at least cover the addition and subtraction of matrices today. Then I yeah.
So this one, the V1, if it's a number, how will it be like?
It can be the same 1, 2, 3, 4, 5 numbers. When you transpose it, this
Okay, so
1, 2, 3, 4, 5. So let's see. It was okay. Let me 1, 2, 3, 4, 5. Let me use, let's see, 2, 4, 6, 8. Right? If they tell you to transpose, now we have column 1 and then row R1, R2, R3. Right. So now row will tend to column and column will tend to row. So now how many columns do you have? 1. And then we have how many?
Yeah.
4 rows.
4.
So now Now the column will rather tend to 4. So now it will now be
1,
2,
2,
4,
4,
6,
6, 8,
no, it is
2. Okay.
right. So now this is how it will look like.
Okay, so that's for the vector.
Yeah, no, that's for solving for transposition.
Transpose.
Yeah.
Okay.
Now you see column as 10, 1, 2, 3, 4.
4.
And then now row is rather 1.
Mm.
So that's how the transposition is. So when you transpose, row will become column and column will become rows.
Okay.
We mu deɛ ɛnhyɛ da nyɛ hwee o. Ɛmba exams mpo. It's just that ɛbie w'adwene towards the alpha point and it here. So any m dimension. So what is m?
A row.
So they say any m dimension vector corresponds to a direct. So meaning that whatever I say, you can plug it here. So you can see 1, 2. So 1, 2. There is it here that they plugged here. 1, 2. There is it here. And then you have 1, -3.
3.
2. 1, -3. So meaning that whatever you do on a matrix, you can plug it on a graph. That's what they basically mean. So now let's go to scalar multiplication. So scalar multiplication simply means that you can scale a matrix. So meaning that you can multiply matrix by any number. Going through this is just make a get. We know compound numbers of a bring of unity. So meaning that the way we can multiply, let's say 2 times 3, right? The same way we can also multiply 2 times a matrix. You understand? So for example, what we are seeing here is a, right? And now they are multiplying 3 by a. So mean that 3 will multiply everything in a. So now 3 times 2 is what?
6.
So that's what we are seeing here. 3 times 4 is what? 12. That's what we are seeing here. 3 times 3 is what? 9. That's what we are seeing.
9.
3, 5, 15. So 3 will basically multiply everything in here.
Everything.
So this is the scalar.
Okay.
That's what we have here. Mean that 3 we can multiply a matrix by a scalar. That's what. So for matrix being multiplied by a scalar, we don't care about the row or the column. It will multiply everything in it. So whether it has only 1 row or 2 columns or 2 rows, anything, being a scalar can multiply everything. But if let's say a matrix is multiplying a matrix, right, and a 2 by 2 matrix is multiplied, let's say 3 by 2 matrix, right? It won't work. It won't work by you do what you do while that's it. It can't work. So, but you understand up to this point, right?
Yeah.
Okay, so by example, let me give this example of let's say 1, 6, 7, 2. This is, let's say, B. So I want to see 4 B. Please, can you try and then give me the answer?
So it will be, is the first one 1?
Yes, the first one is 1.
Okay, so it will be 4, then 24.
4, 20.
24.
Okay.
And then this one will be 28,
28,
and then 8.
then 8. Correct. So you see, it's not difficult. You see, it's not difficult, right?
Yeah. Yes.
So I'm left with 10 minutes. I want us to cover at least addition today because we'll be doing this every day. All 2 weeks, we cover up everything. So now this is addition. So basically, what they are talking plenty here is before a matrix will be added to a matrix, right?
Mm.
The row and the column should be the same. So
Okay.
3 by type it. So let me read it, but I just wanted to explain it. So let's say let A, which is Aij, and B, Bij denote 2 M times N matrix, which is row by column matrix. Then the sum A plus B is the matrix Aij. So meaning that whatever is in A, the same row will be added to B. So let's say 3 by 3 matrix. Right? Matrix can only be added to a 3 by 3 matrix. So same thing to subtraction. And as subtraction is spelling wrong. So meaning that wrong go.
And then
I find it out. So meaning that a 3 by 3 matrix can only be added to what? A 3 by 3 matrix. You can't add a 3 by 3 matrix to a 2 by 2 matrix or a 2 by 1. You understand? So
Yeah.
that's basically it. So if we have something like this, maybe say example, woman. The whiteboard. Yeah, example.
She said it was able to talk on them.
Or the young fan say this. The fan said this is a 3 by 3 matrix. It can be added to this without any problem. Right? But something like this, something like 2, 4, 3, 2. Need them pay £2. Cannot be added to something like 1, 2,
1,
3,
2,
1, 2, 3.
3.
They cannot. We call this undefined. Undefined. So since this is a 2 by 2 matrix, it cannot be added to a
2 by 3.
a 2 by 3 matrix. You get it? So the same way as since this is a 2 by 2 matrix, it cannot be it cannot be separated from a 2 by 3 matrix.
Matrix, okay.
You get it? So now if we want to add this one to this one, we take row 1 here and then row 1 here. So here will be 6 plus 2.
Plus 2.
Then this one will be 12 plus 4.
12 plus 4.
Get it? This one will be 3 plus 9.
Okay.
Right. And then this one will be plus 5.
5 plus 5. Okay.
And this one will be 4. This one will be plus 4. This
So
one,
it doesn't matter. You can bring the 12 to the A part to right.
yeah, you can bring
You
it
can
up.
multiply it anyhow.
We are not doing much.
Is it like you're bringing the A to the like the if let's say maybe this one is B, so you're bringing the 2 to the 6, but you can also bring the
But
6 to the 2, right?
in addition there they are commutative. This plus this will be equal to this plus this.
Mm.
But in
Okay.
subtraction there they are not. So in addition, you can add 6 plus 2 and you get it. You can add 2 plus 6 and you get it. Right?
Okay.
Yeah. But in subtraction, when you subtract 6 from like 6 minus 2 is what?
4.
6 minus 2 is
But
what?
2, 4.
But 2 minus 6 is what?
Negative 4.
So you see they are not the same.
Mm-hmm.
But if it's addition, yeah, you can do it anyhow and you arrive at the same place.
Okay.
So 6.
6, 1, 8.
Basically, now it will be 8. Here will be 6.
16,
Here will be 12.
12,
Here will be 20.
20,
Okay, here will be what?
16, 16, and then 24, and then 24 again, 4, 32.
So this matrix by this.
Mm.
This is it.
Okay.
So you get it.
Yes.
Up to this point, is there any question?
No.
Are you sure everything is fine?
Yes.
So after this one, if I give you test, we're turning in our own.
Yes.
So I'll end the class here. I will send a recording and then I'll
Okay.
send an assignment. So I want the assignment to be presented before in 9 o'clock.
Today.
No,
Ochina.
tomorrow 9 o'clock.
Okay.
Okay.
Thank
Okay.
you very much for joining.
Welcome. Thanks.
You always welcome. So tomorrow we'll do the
Welcome. Thank you.
multiplication. Tomorrow we'll do the multiplication, and then the multiplication is not difficult, but it's confusing. The way you're already confused with the rows and column, that's what will. But tomorrow I'll teach you how to do the multiplication with your own eyes and then with calculations. So I'll teach you how to do matrices with calculator. So tomorrow the addition of matrices I'll teach you, and then on calculator, and then the multiplications I'll teach you, and then how you can do it without calculator I'll teach you. So tomorrow to the same tomorrow then by 9 o'clock prepare the and I'm here. And then me imagine say me that kiti bi o me hwe na me ko. Then me for So see you tomorrow. Thank you very much.
Okay. Welcome.
Bye.
Bye.
Bye. Bye.